to be talking about parent functions and transformations. So the first thing that I'm going to do is I'm going to fill in this chart of parent functions. So let's start filling this in. So the rule for a constant parent function is the f of x equals 1. And the graph is going to be a horizontal line on 1. The domain for this is going to be all real numbers. And your range is going to be y equals 1 because it's the only place that it hits the y-axis. Our next one is linear. And our linear function rule is f of x equals x. And that graph is going to be a line through the origin with a slope of 1. And our domain and range on this one is going to be all real numbers. Okay, next we have absolute value, which is the f of x equals the absolute value of x. Our graph is going to be start at the origin and be a v up 1 over 1. Okay? The domain for this is all real numbers, and the range is y is greater than or equal to 0 because the graph starts at 0 and goes upward in the positive direction of the y. Our last one is our quadratic, which is f of x equals x squared. Our graph is going to be parabola at 0, 0, 1, 1, 2, 4. There we go. Our domain is going to be all real numbers. And our range is going to be y is greater than or equal to 0, just like the absolute value function. Okay, next we're going to talk about transformations. Okay, so we've got to define some of these words. So a transformation changes the shape, size, position, or orientation of a graph. Okay. Now, translation is a type of transformation, and one way to remember this is that it is a slide. We can slide that graph around. It doesn't change shape, but we can just slide it around. So this shifts the graph. Horizontally, or vertically, now a reflection flips the graph over a line. Now our next one is a vertical stretch and a vertical shrink. I'm going to show you what this would look like if we did a vertical stretch. Let's draw, let's say, an original absolute value, a parent function of absolute value. And if we were to stretch it, it actually gets thinner and it stretches up. And what that looks like, if we take the f of x equals a times the absolute value of x, for it to be a stretch, the a has to be greater than 1. For a vertical shrink, it's going to shrink it down and make that graph a little bit fatter. So let's do the original in green, our parent function in green. And then the shrink to be a little bit fatter, okay? And for this one, a has to be in between 0 and 1, something like 1/2. All right, so we're going to take these things, put them together, and we're going to practice. Okay, the first one says identify the function family to which f belongs. Well, if we look at this, this is a quadratic. And the parent function is the f of x equals x squared. So if we look at this, visually we can see what's happening from the original graph. From the original graph, it's reflected over the x-axis. It's moved upwards by 3, the vertex has. And it's been stretched out. It's a little bit thinner. Okay, so we can see this visually, but we also can gain this information right from the equation. So our reflection is gained from this negative right here. So this would be the reflection on the x-axis. The stretch is gained from this 2 right here. That's our a value. So that's going to be our vertical stretch. Okay, and our very last one is our translation, which is this plus 3 at the very end. That one is going to be our vertical translation three units up. So we don't even need a graph to see what these transformations are. It does help to verify our answer, but we can gain it just from the equation. So let's do another one. This time we're going to graph this. We're going to graph the function and its parent function, so we're going to graph two things, okay, and then describe the transformation. All right, so if we look at this, this is a linear, so we're going to be drawing a line. And the linear parent function is f of x equals x. Let's draw that one first. Let's see what that looks like. So we're going through the origin with a slope of 1. Let's do that in blue. Okay. Okay. And now let's do the f of x equals x minus 6. Now we can use slope-intercept form. Our intercept is at -6, and then a slope of 1. All right, connect those. Visually, you can already see that this graph has been pulled down by 6 units. Okay, so we can write that as a translation, a vertical translation, six units down. And if we take a look at the equation, this -6 gives us that vertical translation. Okay, so let's do another one. Okay, we have the h of x equals the quantity x plus 4 squared. Now this one is a quadratic parent function. So this is a quadratic. And our quadratic is going to be the f of x equals x squared. And we're going to be drawing parabolas for this one. Now, if you can't remember how to draw a parabola, we can always use a table of values, okay? So let's do a table of values for the parent function. So we have an x, x squared, and then y. Let's just do 0, 1, and 2. Really small ones. So we have 0 squared, 1 squared, 2 squared. So we have 0, 1, and 4. So let's plot 0, 0, 1, 1, 2, 4. Now with a parabola, don't forget to reflect it on the other side. So we go over here and over here. So we have a parabola like that. Okay, so now let's do a table of values for our h of x, x plus 4 squared. So let's do table of values. And I'm going to choose -4, -3, and -2. I'm going to choose those values for this parabola. Okay, so I'm going to do -4 plus 4 squared, -3 plus 4 squared, and negative 2 plus 4 squared. So I'm going to get 0, 1, and 4. So I have a negative 4, 0, negative 3, 1, and let's reflect that over, and then negative 2, 4. Okay, reflect it over. And here we go. Here is our h of x function. Now, if we just look at this, we can visually see that it moved horizontally to the left 4 units. So we can say it's a horizontal translation 4 units to the left. And if we look at our function, this x plus 4 is what gives us a horizontal translation 4 units to the left. Let's try an absolute value. Let's do one of those, okay? So this one is an absolute value. And absolute value, parent function is the f of x equals the absolute value of x. And so for this one, we can do a mini table of values. So we can do 0, 1, 2. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Okay, so we can go at 0, 0, 1, 1, 2, 2. And I can draw those. And don't forget to reflect on the other side. Okay? So now let's do a table of values for our other function. And I'm going to try a 0, a 2, and a 4. Let's try those out. Okay? So 1/2 times the absolute value of 0 is 0. 1/2 times the absolute value of 2 is 1. And 1/2 times the absolute value of 4 is 2. So let's do that. We're at 0, 0, 2, 1, and then 4, 2. And let's reflect those over. Now, if we look at this, we didn't shift it at all. Okay, we didn't move it up, down, left, or right, but we kind of squished it down, and that is a shrink. So this is a vertical shrink. And we can see that by this 1/2 in front of the absolute value, because our a value was in between 0 and 1. So now we're going to put all of these things together. Okay, I'm going to kind of give you a hint of how to look at these by the equation, and then I'm going to show you how to graph this in a graphing calculator. Okay, so the first thing is that the negative in front of the function is going to give us our reflection. So we know it's a reflection. If I have a number inside, either parentheses or an absolute value, that's going to give us a horizontal translation. And it always moves opposite of what the sign is. So this one is going to move to the right. Since it's negative, we're going to move to the right. So it's a horizontal translation, 1 unit to the right. And the very last piece, if it's on the outside at the very end, this negative 1/2, this is going to be our vertical translation. And it's going to be the same. If it's negative, it goes down. If it's positive, it goes up. So it's going to be a vertical translation down a 1/2 unit. Okay, so let's pull up my calculator real quick. We're going to look at this calculator, and we're going to graph this in the calculator. And then we can compare these to be able to see what kind of transformation is going on. All right, so the first thing I'm going to do is I'm going to actually put this into the graphing calculator. So I'm going to say a negative absolute value, and I do x minus 1, and I arrow over, and then I do minus, and I always put parentheses around my 1/2, around my fractions. 1 divided by 2. Okay? And then in my y sub 2, I'm going to put the parent function so we can compare it. So I'm going to graph this. Okay? And the red one is the parent function, and the blue one is your new transformed function. And all of these things happened that we listed. It reflected over the x-axis, it moved to the right by 1 unit, and it moved down by 1/2 a unit. So we can use our graphing calculator to determine our transformations and check our answers. Okay? Now our very last piece is about domain and range. Okay, about domain and range. It says identify the function family and describe the domain and range. And you can use a graphing calculator to verify your answer. So for number 1, this is absolute value. Number 2 is going to be linear. And number 3 is quadratic. So what I want you to do is I want you to graph each of these in your own calculator and then compare it to what the answers are for the domain and range. So I'm going to give you the domain and range for all of these. So for the absolute value, the domain is all real numbers, and the range is y is greater than or equal to 2. All right, and then you can graph this in your graphing calculator and see what I'm talking about. The next one, the domain and range for a linear, is all real numbers for both. And then for the very last one, the quadratic, the domain is all real numbers. And the range is going to be y is less than or equal to 6. So put those into your graphing calculator, double check to see if you get the same answers as me.